Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics Electricity at Home. So today we'll be covering mainly how electricity gets to our houses. Last time we covered National Grid, where I kind of explained to you how that electricity gets from power station to our houses. Now we are going to focus mostly on how to get that electricity from the plug in our house to an appliance, to your TV, your kettle, your cooker if you got electric cooker, and any sort of appliance that you may be using. So without further ado, let's get started. So first of all, nice and simple, how do we supply electricity to an appliance from a very simple outset? Well, you just grab a socket, you just grab a plug of that appliance, and then you stick it in your main supply socket. And then your device starts working. It has electricity and it starts working. Why is that device starting to work? Well, because it has current going through it, and it has potential difference going through. Essentially, it has electricity going to it. So in UK, the main supply provides alternating current. We'll be focusing a bit more on that in future videos, but there are essentially two types: alternating current and direct current. Alternating current keeps alternating between a plus and a minus side. So essentially, every so often it switches its plus and minus sides, where direct current stays the same. It has plus and always at the same end as it does minus end always at the same end. So anyway, so we have main supply, and that is alternating current at 50 Hertz. 50 Hertz means that it switches plus and minus 50 times per second. That's 50 Hertz, that's a frequency. So we have main supply at alternating current at 50 Hertz, and in UK, main supply will provide an appliance with 230 volt potential difference. Appliance may have resistors to change that, but at main supply we have 230 volt potential difference. Now, this may vary in other countries. This may vary slightly in other countries. It may vary in USA. It may vary in Europe. It may vary in Asia. Wherever you are, that number may vary. But in the UK, it is 230 volts. So that's one way we can supply electricity to a device. Another way we can supply electricity to an appliance or a device is by using batteries. As usually that goes for devices that don't need quite as high current, that don't need quite as high potential difference either. Because batteries, whereas in main supply you have 230 volts, in a battery, like a big square battery, that's, if I remember correctly, that's around 9 volts. Either way, that's a massive difference. So batteries tend to be used for appliances where you don't require such a high potential difference. So battery is a direct current, as I already explained. In battery we have a minus end and we have a plus end. We have a positive end and we have a negative end, and that dictates which way the current will flow in the device. And that stays the same. That doesn't change. That stays the same. That's the main difference from alternating current. It stays the same. And with that, obviously, with battery devices, dependent on the type of battery we use, we will have variable voltage, variable potential difference, because that just comes down to the potential difference that the battery provides. And we can have batteries that are 9 volts, we can have batteries that are much lower, and in some cases actually higher. So that's in the simple outset, that's how we can supply electricity to our appliances or devices. Now, let's go back again to the main supply. Why are we using alternating current in the main supply? Why don't we just keep it simple and we keep direct current? Well, that we'll go into a bit further, but is mostly a byproduct of the way transformers work. The way transformers increase the voltage, as we discussed in the previous video, the way transformers increase the voltage, increase the potential difference, the way they work, they tend to cause alternating current, and we just basically roll with it, and that's what we're using because it's not a big issue. So that's why we're using alternating current. So now what happens in a plug? When you plug something in, what is in the plug and how does it work? Well, here we have a diagram. And the plug consists of, essentially, simply looking at the plug, it has 3 basically sticks that go into the main supply circuit. And those sticks are connected to 3 key cables. They're the very important cables that we will go over in a second. Plug also has a fuse. Now, fuse is here, usually near the live wire, which we'll go into in a second. Fuse essentially is a safety measure. When a fuse can deal with a certain current going through it. And when a current going through a fuse gets too high, it will blow. It will basically break and stop working, and it will break the entire circuit and stop the appliance from working, switch it off. So if the current gets too high from any sort of breakage or maybe thunder hitting the house, the fuse will break as a safety measure to stop the appliance from catching on fire or stop it from shocking somebody. So fuse will break, and that's that. Current is broken, appliance stops working. However, we also have 3 cables. So first of all, let's go a brown in UK. Now, in UK, all of these cables have the same colors. In a different country, that may differ, but in UK, these colors are the same in every plug. They should be the same in every plug. So here we have a live wire. Live wire is brown. I hope you can see it on a picture, but in either case, live wire is brown. And live wire is the wire that actually supplies the potential difference. It supplies the current, it supplies the potential difference. So it is at around 230 volts because that's the main supply in UK. Obviously in a different country it may vary slightly. So live wire supplies that potential difference. Now what happens? So here we have a live wire, and then so that potential difference is supplied here into the sort of the tooth or the stick, whatever you want to call it. And then that enters the appliance. And then the appliance completes a circuit. We have it going through an appliance, whatever the circuit in the appliance is. We have the current going through there. And then it's completed by entering the neutral wire. The neutral wire contains, basically completes the circuit. It brings the current back. It completes the circuit, so we can have that appliance working under normal working conditions. So if everything is fine, that current will sort of come back via neutral wire, and neutral wire is usually at 0 volts, because by then we sort of used up our potential difference. So usually, there may be some variations, but usually neutral wire is at 0 volts. The main job of it is to complete the circuit. That's the main job of it. However, we have another wire. In UK, not everywhere, in UK, we have something that's called an earth wire. It's a green and yellow cable. Neutral wire is blue, by the way, if I haven't mentioned it. Earth wire is green and yellow, and it is also at 0 volts. Now, what is the function of earth wire? Earth wire is another safety measure that we get on top of the fuse. Because if, say, a wire is broken in an appliance, have exposed, if thunder hits the house and it causes a massive increase in current, what may happen, especially if the wire inside an appliance is broken, is that if an appliance is metal, the casing of the appliance is metal, it may actually start carrying potential difference, because the broken wire will start touching a metal part of the casing, and then the metal casing essentially becomes a part of a circuit, and it may carry potential difference. So basically, if somebody touches that appliance, it may give somebody an electric shock. So that's very dangerous. So earth wire is there to hopefully counter that. Earth wire is basically we have another third tooth or a spoke or a stick coming out on the other end, and that is connected to an appliance. It's connected usually somehow to the casing within the appliance. And if there is a potential difference running across the casing of an appliance, then that potential difference, that current will basically be drawn away from that casing through the earth wire. The earth wire will basically bring out any sort of potential difference of a current in a case where the casing may momentarily carry potential difference across it, but there is no stable circuit. It's a one-off thing. Then earth wire will basically bring out all of that electric charge, all of that current, and potential difference will be brought down to zero, because earth wire will complete the circuit with the casing of an appliance, and it will take it back to transformer. At the transformer side, there is a wire going to the ground, and essentially it's called grounding wire, and that's where all that casing current and casing potential difference will go to, and it will be dissipated. So earth wire is an important safety measure. So those are the most important wires in a plug, and they are very important because obviously because we have such a high voltage going across the main supply, that electric shock can happen. If you have a large current going through, basically if you say stick your fingers into those two holes, essentially you become this appliance. The current will flow through you. And if that current is high enough, it can cause serious harm, or it can even kill you if it flows through your heart. So, and obviously that's because we are completing the circuit with ourselves in that case. So because of such a risk, there is a number of safety measures, the fuse and the earth wire, that help us minimize the risk of electric shock in case of damages to appliances, such as those that could momentarily expose the casing to have a current or potential difference across it. So obviously these safety measures are very, very important. This is it for today, guys. Thank you very much for watching my videos. I really appreciate when you guys watch my videos. If you want to stay up to date on daily math, science, and some biomedical science videos, as well as some career building type of videos, hit the subscribe button below. Don't be shy. If you think this video helped you, give me a thumbs up. Thank you again for watching, and see you next time.